Hello, this is the first time that I'm giving that talk, so expect some kind of inconsistencies. The talk is named I Will IDOR Myself In. For those who you don't know what IDOR means, it means Insecure Direct Object Reference, or how everyone else is saying it, plus oneing your parameters and other tales from API crypts. First of all, an introduction. I'm Greek, as you can say from my speech. I'm currently a CTO at a French startup which is called Tremo. It has nothing to do with security. It's a compliance and reg tech, regulation tech startup. My research interests are mainly API of IoT devices and industrial IoT devices and web application security in general. I'm developing a machine learning tool to find API flows. That's part of my 11-year PhD that I'm just not going to finish at any time soon. And my younger one said, I'm not even trying anymore. So. And you can find me on Stykas on Twitter. I'm going to start with a really good what API stands for. This is from MuleSoft, as you can see on down there. API is the acronym for Application Programming Interface, which is a software intermediary that allows two applications to talk to each other. And many more words. It means that whenever you're talking something to a backend, to the internet, you're talking to an API. Where are APIs used? They're used on IoT devices, they're used on web applications, they're used on mobile applications, they're used in industrial IoT, they're used in vehicles, they're used in chargers, they're used in pretty much everything. Whenever you're opening up a mobile application and you're interacting with a device, you are using a two-way API. You are doing a call to the API, and the API is also doing a call either via MQTT or HTTP to the device. The vulnerabilities, back when I started pen testing 7 or 8 years ago, we were always saying, it's just an API. You cannot do anything really bad with that. Well, you can gain full functionality of all the IoT devices. You can make them do really, really unintended things. You can punch through firewalls. So keep in mind that if you have your IoTs in your same network, and someone compromises your IoT via an API or any other way, he can pivot into internal networks, and he could reflash and potentially break the IoT device. The other attacks that we are going to see is SMS attacks. You can use, if the IoT device has an SMS, a SIM in there, it could be used to phishing or win Eurovision, as I usually say. So you can send 1,000 or million of SMSs if you are good enough. You can also distribute a denial of service attack, as Mirai did back in the day. You can do ransomware attacks on the same IoT device, and when you're using an API, you don't need to shut down, you don't need to search for anything, you're just accessing the API, and when you are moving laterally, you can find all the devices that you want. The last couple of years, we have seen a lot of people using third-party backends, which means that, as you can see from there, we are hacking an IoT thing. We end up on a third-party backend, which has access to a lot of other IoT things. The last example that I have is I have done a charger hack. We're going to see it, a car charger hack. And I ended up with a couple of million devices, which were not only chargers, but also TVs and a lot of other IoT devices. The special device that I always like attacking is industrial IoT. Why is that? Because historically they're isolated. So if you get access to an industrial IoT, you are respected and accepted as authenticated. They have a really long lifespan, so you will be able to see things in industrial IoT that are older than me, and I'm close to 40 right now. They're rarely updated, so you will see a lot of TLS issues, a lot of issues that you never ever would expect to see in 2022. They're safety critical, they have a high uptime, they have unencrypted protocols, which means that once you're in, you can sniff everything. And usually, when they want to make it smart, they end up with IP to RS-232 or other kind of monstrosities that, yeah, they're just putting serial into internet. And as Mikko Hipponen said, when it is smart, it's vulnerable. So what's the plan? How we're going to approach the talk from here on? I'm going to present you with some vulnerabilities. It's mostly rewarded OWASP API top 10. You have to read it, you have to understand it. It's pretty easy to replicate it. The exploitability ranges from really, really easy to just easy. There's nothing which is really like kernel hacking or anything really extreme. I always like the easy way. And the severity is from bad to, I don't know, nuclear bad. I have to say that before I start presenting API Research 101, it's quite tricky when you're doing API research. In the UK, there is a law which is called CMA. In the EU, we also have a Computer Misuse Act, I don't remember its name. It's quite easy to break it and become a criminal just by doing some API testing. Never, ever interact with a device that you don't own. If you, by mistake, which is quite easy to be done, do and interact with a device, or you get a platform admin, that would be breaking the CMA, notify the vendor immediately, and hope that in good faith, you're not going to be under law. Whatever is with red on my talk is breaking the CMA, don't do it. So, we're starting with classic IDOR. IDOR stands for Insecure Direct Object Reference. You would have to learn that when you're authenticated, you are not authorized. If you don't learn it, API Jesus will be after you. So, what is the classic IDOR? It's the classic +1. When you see a parameter and it has a number, and if you go up 1 or down up 1, and this device is not yours, and you can interact with it, you have a classic IDOR. It's a typical symptom of missing authorization. GUID is not the solution. The fact that I cannot +1 or -1, but I do have access if I have a way to either get from the leak or somehow guess the GUID means that this is not solved. This is just another hurdle that I would have to pass. It could leak into leaking everything and breaking everything. The first example is Viper Start Smart. That's a car alarm. You can see it in here, right? So you are updating your own. You can see on the top the number 861772. When you are updating 861771 with your email. Also, if you are a developer and you have seen something like that email, ego@mailinator.com, I'm sorry, I have tested your system. Sorry. It's not bad. So, what's that IDOR? If you could change, that's how anyone could update their own profile. So you would just change the ID in there, and you would update someone else's profile, which means you could update the email, the password of anyone else, then go to his vehicle. Actually, you could geolocate his vehicle, so you could start moving around, changing passwords, find the Porsche, I don't know. You're a Tesla guy, go to a Tesla, unlock the car, start it, because it also had the start-stop, and then drive away with it, just with a +1. The second one is even funnier. It's a Chinese car charger, Project TV. It's probably one of the worst APIs I have ever seen, and I have seen a lot of APIs. That's the whole request. Every request is that. You can see that it has a charge ID, and it's missing something quite like the most important stuff. It doesn't even have authentication. So it was checking for a login. It was saying, yeah, this is your login, this is your charger, and then every request was done anonymously. So you could just do all the chargers and do full functionality on all the devices. You could lock it, unlock it. You could firmware update it because, yeah, who needs signatures on their update? You could backdoor pivot into the internal network. That should also be read. Sorry. PII leak, you could brick it, and you could also take a platform admin on the server. Again, just with a +1. The solution is you have to learn that authorization doesn't mean authentication doesn't mean authorization. If someone is authenticated, it doesn't mean that she should have access into all the devices of your platform. Second issue is lazy REST implementation. That's called mass assignment on OWASP top 10. Usually, what we do, what the automated tools do, and what my AI tool tries to do is it gets the request, it gets the response, and it tries to find if something that is in the request, in the response, is not in the request. This means that someone might be using an ORM, object relational mapping, lazily, and it could just pass the full object. That means that you could change things that you shouldn't. Another charger, a really, really good API. That's one of the best APIs that I have ever seen. But yeah, unfortunately, they were passing on their profiles your own roles. So, and when I passed a role which was test, it said, no, this is not an accepted role. You could also pass, user, account owner, admin, and tenant admin. So admin and tenant admin looks really nice, right? So what was that? Total compromise of everything, PII leakage. I had all admin functionality. I had platform admin. I had server admin. I could literally just delete everything. Don't do that. That's also on red. What we should do to fix that? You should always need to check response and request. No, that's not what it should say there. So what you should do is never use a norm lazily. Always whitelist what you are accepting. Never blacklist. Always use the whitelist. So if your profile, you should only, you are trying and you are accepting only username, password, you should accept only those and not the roles. There is no way anyone should be able to self-upgrade themselves to anything else. Another lazy REST implementation, it's the Troy Hunt story. As you can see in here, this was a kids watcher, which had a one-press phone call, and if you were a helicopter parent, you could see where your kid was. This is an open API. You can see the filter that says family identifier equals with 2034. So if you just remove the filter, you would get all the users. Why not? If you change that family identifier, you would get some other family. And the even worse thing is that you could do that and change the location of somebody else. So this ended up with me. This is Troy Hunt's daughter, and I'm in Greece. She's in Australia. You're not going to hear it. The watch is ringing. She's responding. She's seeing at her watch that dad is calling her. Somebody else's dad, her dad. That's Troy's.
Hi.
And she responds to me, and I respond to her. So that's really, really, really lazy implementation. What I could do, total compromise of everything, PII leakage, all admin functionality, platform admin. Again, a really bad API. If possible, avoid using functions that automatically bind the client's input into code variables or internal objects. That's a WASP recommendation. Whitelist, as I said, if applicable, explicitly define and enforce schemas for input data payloads. As I said, try to whitelist, try to use models that have only the data that you accept, that you should accept, and process them. User group juggling. This is my favorite vulnerability. A lot of people don't look after it. So what you're doing is when a web application or an API is giving you user group, you try to trick it into adding your user into another group, into changing your group into someone else, or adding your group into another company, because that's what you do. Multiple potential ways of user group juggling. I just told you a lot. You have to be creative. The developers cannot have, they should cover everything, but they usually don't. If create is not vulnerable, always use edit group, because more often than not, the edit is more insecure than the create, and could lead to platform admin, account takeover, and a lot of things, because if you could add a group or an admin on the company, on the initial company group, you practically have a platform admin. You know, SonicWall is one of the, I think, the 5th biggest firewall provider. Can you see the issue in here? They're providing the party group ID, and I just added somewhere on another party group ID. So if I went to party group ID 1, which was SonicWall, and added it as an admin, I could have done all those. SonicWall accepted that, said about that. I didn't do that. I'm not a criminal. So I could have access to routers, firewalls, VPNs, security reports, traffic analytics, all those things. And it was really, really bad. We were looking at 50 million devices and I think 55,000 internal networks behind the firewall that we had access, I had access, full root access. Mimosa is another antenna provider / firewall. It is being used by some military. You can say it again, right? You're adding on 1, 2, 3, 4, but the organization is 1, so I just got admin on organization 1, which was the Mimosa root account. All users in PII leak, access to all internal networks, full organization access. Mimosa just said thank you, and that was it. Both of them were really cool. They fixed it in less than a workday, which is really, really nice. Bugs are going to happen, issues are going to arise. It's how the providers treat the whole security issue that makes them look good or bad. You should never be lazy. Actually, be lazy, but when you code, don't be lazy. And always check for correct authorization, check create and edit groups, especially on user access functions. When you have user access, when you're creating a user, when you're editing a user, check your ACL code meticulously so that you know that everything went well. Second level IDOR, which means when there is an IDOR, there is an ID, which is okay, but there is a second level in there that it is not checked, and you can do it, you can manipulate it there. Check every combination where an attacker could leak into info leak and account takeover, check everything. There is not a lot of cases that everything is vulnerable. One parameter is enough to be vulnerable so that you can take an account takeover. Wallbox, another card charger. That doesn't so in here, the access config, which is who could access it, the 101.612 was not vulnerable, but you could pass any charger that you want. So I could pass to my user having access to all the chargers and ended up with total control of all the chargers, lock, unlock any charger, PII leakage. I didn't got platform admin, so I guess it was not that bad. Now, that one is really nice, but REST juggling is, you have to read, understand the REST principles, and when you're getting a user or getting a device, usually when you post or put, it will update, edit, or delete it. But developers are being lazy, and again, they're using a full, what they're calling a full controller mapping, so they're also using post-put without having the implementation in there. So you could trick the server into doing something that the developer would not expect it. It could lead into platform admin, account takeover, and I don't know, everything. Now that's a bad thing. I had a really cool vulnerability in here, which is still not fixed. It's, I'm not going to put, sorry, I'm not going to put the 0-day for you. It's like I was 50-50 into dropping it because it's already 3 months, but as this is an IIoT, I'm not going to drop a 0-day. Sorry. So never use the full controller URL mapping unless you know you will need everything. So if you don't want to update your charger, don't have the put VERB. Always check for proper authorization and be extra careful on what you do with the URL mapping. Hidden endpoints. So when you're an attacker, you should read JavaScript, you should get the Android source, you should get the iOS source and get all the endpoints from there. If you don't see anything in your interactions when you're doing your tests with the mobile application or the web application, this means that this endpoint is either obsolete or for a user that with privileges that you don't have. So this is an interesting endpoint. Use automated tools. VERB has a really good extractor for all endpoints. Try to think where the developers would potentially cut corners and go there. And it could lead into really, really interesting stuff, as you're going to see later on. First is Pandora. Again, if you're a developer, never ever say you're unhackable. No one is unhackable. If they say it's unhackable, it attracts a lot of people that you don't want to attract. So, what in their JavaScript, I could see that there was an API Sputnik workers ID. This was an internal workflow that Pandora had so that it could update the user to change their email to a Sputnik Pandora email and then update it. What we could do is change the ID, change the email, then change the set a reset password, and boom, geolocate any vehicle, unlock, stop a car. That also had a really nice internal microphone that you could snoop into users and profit. SE Tracker, I don't know if you know it. It's probably the biggest Chinese GPS key locator. It had a JavaScript file that was named backup.js. You should look at, when you see backup.js, you look in there. It was referenced in a map. It had all their backup procedure in there. It was tarring all the source code and putting it in the web root. So with a really strange file name, but I had the file name. So I downloaded all the source code. This is red, don't do it. The source code had static keys, SSH passwords, database passwords. It has everything. You could get full RC on 40 servers. You could do anything on 50 million devices. You could geolocate any device. You could use it to send any text, SMS, call any phone, use it to win Eurovision. So, I don't know, 30 million devices in Europe. I could send and make Greece, I don't know. Norway win Eurovision. And you could also listen to someone from the microphone. Hide at endpoints, that's also a really nice one. ChargePoint is one of the biggest public chargers. It had a public GraphQL with no authentication, just on the open internet. It was not used, but it was there on their Android application, and it was leaking their full schema. You could charge for free anything. You could stop a car charger. You could, I don't know, you could PII leak. The schema also had some credit card tokens. I didn't access them because, yeah, I want to go back to the US at some point in my life. When you're developing, keep in mind that people will look and decompile your application, so don't hide in plain sight, don't be security through obscurity, it doesn't work. Always verify that proper authentication is being done on your admin endpoints. Test for broken workflows. The thing with Pandora, it should have been done only from admin. A broken workflow should have a broken workflow test, automated code testing should have gotten it. So back to recommendation. It's critical to authorize all requests. Authentication is nothing if you don't authorize. As I previously said, it's usually 1 or 2 requests that have been forgotten that you can use to get platform admin. Once you get account admin, it's usually easy to go to platform admin. Check that every request is authorized. Never, ever trust user input. Thank you. And any questions? Okay.
Any questions? Anybody? You had some more time. All right, guys in the back.
So what does your normal workflow look like? Do you do a lot of automation, or is it mostly manual work?
For pen testing, usually you also, I'm mostly focusing on logic flows. So as you have seen, obviously I also found a lot of SQL injections, XSS, all of those stuff that can be automatically tested, but that can be easily automated. The logic flows, I have built an AI tool that is trying to find a lot of stuff, but it's usually just trying to understand what the developer wanted to do and trying to circumvent around it to do something else.
Was there another in the back row here? Yeah.
More or less the same question, but any particular tooling aside from the obvious like VERB suite or gripping through source code or something like that?
Usually I use VERB and then export everything to my AI tool, and actually any proxy could be okay to look at the requests.
Anybody else? Okay. All from the same row. Very curious people sitting here.
I noticed a lot of that is from mobile applications. Do you have any custom tooling for proxying mobile applications and decompiling, or are you just doing it manually as well?
Well, you just put your proxy, then have Frida multi-unpinner to unpin it, and from there on it's just typical API calls for me. I'm not focusing on mobile applications, so if it has root detection or anything else, I usually try the normal stuff, and if that doesn't work, I talk to someone who speaks mobile, because yeah, I'm not an expert in these kind of things. Anyone else? Thank you, guys.
Thank you very much.